So this one says find the area enclosed by the line y equals x minus 1 and the parabola y squared equals 2x plus 6. So this one is a little bit more challenging because if you notice, all the other examples we've done were just y equals something. And so we were able to set those things equal to each other and find out their intersection and go from there. But this one we have a y squared. Is it going to be easy to solve for y there? Probably not, because we'd have to have a square root and a plus and a minus, so that's probably not ideal. So what I'm actually going to do is take these equations and I'm going to solve for x. So this one would be y plus 1 equals x. This one we'd have to subtract over the 6 and divide by 2. So now if I'm trying to find the intersection, find out where they meet, I can set these equal. So y plus 1 equals y squared minus 6 over 2. So if I multiply over my 2, it's quadratic, so set it equal to 0, subtract over the 2y, subtract over the 2. So what multiplies to negative 8 and adds to negative 2? So y is positive 4 and negative 2. So this is different than the others because we're used to having x equals here. If we looked at our graph, we're going to be going between negative 2 and positive 4. Okay, if you plug negative 2 in for the y here, we get negative 1. So we have point negative 1, negative 2. If you plug a 4 in for your y, you get 5. So that's the 0.54. So that's the line. The parabola, again, if we plug in the negative 2, we get the negative 1. And if we plug in 4 for the y, we get this point. So if you wanted to get a more accurate graph, you might need to plug in something else in between them. So if you put in a 0 for your y, we get negative 3. So that will be a possible point when y is 0, your x is negative 3, but that's kind of outside of where we need to go here. If you put when y is 1, for instance, or let's do 2, would be nicer. 2 squared is 4, minus 6 is negative 2, divided by 2 is negative 1. So when x is negative 1, the y is 2. And so this is kind of allowing us to see our graph a little more. It's like a sideways parabola. Okay, so really the endpoints are important. And then beyond that, you just need enough points that you can kind of get an idea of what your graphs look like. So we need to change our strategy on this one because when we've been setting up our intervals, we have our limits and we had the x values for the limits, we had x's here and a dx at the end. But we've already decided it's not easy to solve for y here. So we're going to keep the y's. So I'm going to integrate everything I'm going to do in terms of y. So my y of negative 2 to the y of 4. When you're doing with the x's, you do top minus bottom. when we're dealing with the y's, we want to do the one on the right minus the one on the left. So if we're thinking about the right curve, that would be this line. Minus the left curve is this parabola. How will you know if you accidentally flip those? You'll have a negative at the end, and you know you just need to make it positive for your final answer. Okay, questions to this one? After this, it's really just a matter of integrating. We can clean things up a little bit. We'll get y plus 1. Y squared over 2, that's a 1/2 y squared. Minus a negative, so plus 6 divided by 2 is 3. And so now we can integrate this. So what's the antiderivative of negative 1/2 y squared? Add 1 to your power, so it's cubed, so you need a 1/3 in front, times the negative 1/2, so negative 1/6. Antiderivative of y would be 1/2 y squared. Antiderivative of 4 would be 4y. Okay, so if we plug in a 4 cubed is 64, so that would be negative 32 over 3. 4 squared is 16, times a half is 8, is 16. Put in negative 2, negative 8 times negative 1/6 is a positive 4/3. Negative 2 squared is 4 times a half is 2, minus 8. Let's see. So we get, you distribute your negative, negative 36 over 3, so negative 12. Plus 6, 18. So sometimes you may need to integrate with respect to y. If the original equations aren't ones that you can easily get to be y equals, if you have to get x equals, then we're going to keep y as a variable and deal with that. Is that okay? Why don't you guys see how far you can get with setting up this one? So you gotta figure out where they meet.
I didn't plug them in as you said.
I set, since both of these were y equals, I set these two things equal to each other. So x equals 6 minus x squared. Then I brought everything to one side, did box method. And then to get my points, so I'm graphing this one. So if I plugged in -3 for my x, y equals the same thing.
Okay. Alright, next question.
So for this one, this parabola, we're going to be getting the same points if we just do these endpoints. You know, if you plug in -3 for your x, -3 squared is 9, 6 minus 9 is -3. If you put in a 2 for your x, 6 minus 4 is 2. So we have those. We probably need some more points just so we can kind of get an idea of what it looks like. So if you put in something between -3 and 2, maybe a 0, 6 minus 0 is 6. So when x is 0, we get out 6. Bless you. And now we've got 3 points, which is probably enough for the rough graph, which is all we really need. So we're trying to find this area. So can I do this one in terms of x? Yeah, we got x equals, so that was no problem. So we're going to go from -3 to 2. You do top minus the bottom, so the top was the 6 minus x squared, minus the bottom is just x. So if we integrate, antiderivative of 6 is 6x, minus the antiderivative of x squared would be 1/3 x cubed, minus the antiderivative of x is 1/2 x squared. We plug in a 2, we get 12 minus 2 cubed is 8 over 3. 2 squared is 4 times 1/2 is 2. Put in -3, so we get -18. -3 1/3 is -27 times -1/3 is +9. -3 squared is 9, so minus 9/2. So we get I'm trying to show you guys how to work things out without picking up the calculator immediately. If we want to add those fractions, we need a common denominator. So this one you can multiply by 2 on top and bottom, this one by 3. So 19, if I want to get a common denominator with that, I have to take it times 6. 16 over 6 plus 27 over 6 is 11 over 6. So we get 125 over 6. So I'm probably showing more work than you really have to, but I just really want to show you how to work things out without grabbing the calculator. I want to do one more today, and then I want you guys to start some of your homework problems so I can see what we're struggling with, and I know what we need to work on for tomorrow. So find the area in the region bounded by the line y equals 1/2 x, and the parabola y squared equals 8 minus x. So is this one where we can solve for y? No. So this is one where we will keep the y. So let's solve for x. So if I wanted to get this x by itself, what would we do? Divide by a half or multiply by 2. So we get 2y equals x. This one, you could, if you add over your x and subtract over your y squared, 8 minus y squared. So if I want to figure out where they meet, we set those equal. Let's get it all on one side. Multiply to -8, add +2, so +4, -2. If we want to get a rough picture, these are my y's. So plug a -4 in for your y, you get -8 for your x. If I plug a 2 in for my y, I get 4 for my x. There's my line. My parabola is going to have the same 2 points because we found out that's their intersection. If we just want to get another point in the middle, just pick some y value between -4 and 2. So maybe if you put in a 0, you get 8 for your x. So yeah, definitely 80. We can kind of see our graph looks something like this. Okay. Not a great graph, but it'll be close enough to get us what we need. So if I'm doing the y's, we go from small to large, so -4 to 2. You have to do right minus left. So which one is on the right? Minus the left is the 2y. So we can integrate. Antiderivative of 8 is 8y. Antiderivative of y squared is 1/3 y cubed. Minus antiderivative of 2y is y squared. So we plug in. So we get 16 minus 4, so 12 minus 8/3, -32 and -16 is -48. Subtract that, so plus 48. Combine like terms. 72 divided by 3 is 24. Okay, 36.